Let's do numbers 4 and 5 in this video. So we are finding components. So for the x component here, remember how we draw components? We consider where we're starting and where we're ending. How do we get from the beginning to the end? We would go to the right, and then we would go upward. So this would be, if we call this vector A, this would be AX, the x component, this would be AY. And AX is adjacent to the given angle, so that means that we would say AX is equal to A cosine of 35. And A is 50, so we'll get 41. And then for the y component, it's opposite to the angle, so an opposite component will always use the sine, so it's going to be A sine of 35, and that's going to give us 28.7. Part B here is exactly the same thing. It's exactly the same vector, but we're given this angle over here, but you know that this angle is still 35 here because they both add up to 90. But the point of part B is, what if you are given this angle? How would you do it? Well, I suggest just finishing up the triangle. How do we get from the beginning point to the ending point? Since we're given the angle 55, I would go up, and then I would go over to the right. And we can see that it's the same exact components. This right here is AY, and this is AX. Now this time, AX is opposite of the given angle. So AX would be A sine of 55, but A sine of 55 will give you the exact same thing as A cosine of 35. Likewise with the y component, which is adjacent, it's going to use cosine, and it will give us the same exact answer. C and D are also the same vector, but just getting used to being able to do the problem no matter what angle you're given. And you can always choose what angle to use, right? If you didn't want to use this 55, you could have drawn this 35 here and done this one the exact same way as this one. So looking at C, we have 140 degrees. Now, me personally, I don't like angles that are bigger than 90. I'm just funny that way. So I would actually look at this one first because I'm used to dealing with angles that are smaller than 90. So I would go to the left here and up. So if I call this vector B, then this would be bx and this would be by. So bx is adjacent to the given angle, so it's going to use the cosine, so bx is going to be 100, the hypotenuse was 100 here, 100 cosine of 40. Now bx is going to the left, so I have to make the whole component negative. So the answer will be negative 76.6. And by is opposite of the angle, so it will use sine 100, sine of 40. It's going upwards, so it's positive 64.3 newtons. So back to part C, if you wanted to use the given angle of 140, then what you'd have to do for the x component, which you can still draw the x component here and the y component here. But if you really wanted to use this angle, then you would say bx is 100 cosine of 140. And it'll give you the same exact answer. You don't have to put the negative in because the cosine of 140 will give you that negative. And likewise, if you do by is 100 sine of 140, you'll get the same thing. Just personally, I like to keep my angles smaller than 90 degrees. Let's go ahead and do number 5, which uses some of the information that we found over here. We're adding these three vectors, we've already looked at these two vectors. So I'll go back, call this vector A, vector B, I'll call this one over here vector C. So when we're adding vectors, we're always separating the x and the y components. So on my paper, I'm going to go ahead and separate the components, and I'll write, do a line here. I'm going to do ax, bx, cx, find all of those components, ay, by, cy, find all of those components. Luckily, we already found most of them. This was 41, this was 28.7, this was negative 76.6, by 64.3, and cx, well, we see vector c going down here. If a vector is going vertically, no part of it is going horizontally, so it does not have an x component. Vectors only have an x and a y component when they're diagonal. When they're vertical or horizontal, they only have one component. In this case, it has a y component. So the x component is 0. The y component is going to be negative 75 because the vector is going down. Once you have found all of the components, you add them up separately. This gives you the x component of the resultant. Got negative 35.6, and then over here you add the y components. That'll give you the y component of the resultant, which is going to be 18. Once I have these components, what I like to do is draw them, not to scale, just to see which way the resultant is going. So Rx is going to the left, so I just draw it really quickly. Ry is going up. I draw them tip to tail, not to scale, just paying attention to the direction. So if these are the two components of my resultant, I know that my resultant is going to go this way. And I know that I'm going to have to define this angle right here. So I'm going to use the Pythagorean theorem to find the magnitude of the resultant. And when I do that, I got 39.9 newtons. And then I need to find the direction using the inverse tan of Ry over Rx. And this gave me 26.8 degrees. You've got to be careful when you're specifying the direction. So this 26.8, we know that it corresponds to this angle theta that we drew in our picture. So in a problem, it usually wants you to state the angle with respect to the positive x-axis and going counterclockwise. So that's why in my answer key, I said that the solution was theta equals 153.2 degrees. So that was my answer for the direction. Because if you look at the positive x-axis here, going to the right, and then you look at an angle going from this positive x-axis to the vector, then this angle here, that's what the problem is usually asking for, and that's going to be 180 minus theta. That's how I got 153.2 degrees.